This is what the Big Bang really means. The universe is inflating like a balloon in all directions. If each one of those buttons are galaxies, well, you can see the space and time between them are expanding. As far back as we can see with telescopes, initially the universe was very hot and extremely dense. In fact, the entire universe, all the matter and all the space within it, including yourself, existed in that microscopically small point. Now, we don't know what's beyond that point, but our physics only allows us to see that far. However, we know a great deal about the seconds after the Big Bang. The universe was bubbling with radiation. The universe was so hot and dense that all four fundamental forces of nature were merged into one superforce. But as time went on and the universe expanded, it cooled down. The forces of nature started to break apart in something called symmetry breaking. The collisions of photons that permeated the universe were able to collide together and form electrons and quarks. Then, as the universe continued to inflate and get colder, those quarks combined into neutrons and protons. Up until this point, all that radiation in the universe was trapped. It couldn't escape. The radiation was blocked by a fog of charged particles. That's until about 380,000 years after the Big Bang, when atoms first started to form. As the universe inflated, the universe became cold enough for electrons to be trapped inside the orbits of nuclei. These hydrogen atoms were the first ones that were able to emit all that light that we now know as the CMBR. This is the first image of our universe that we could have ever taken. And this radiation fills the universe 360 degrees around us. Now, about 250 million years after the Big Bang, the universe was still full of hydrogen gas and dust. These eventually became the stars and the galaxies. Now, the first stars were made of hydrogen gas and helium, but how about all the larger elements like iron and nickel and gold? The largest stars are the ones that produce those heavier elements in their cores due to nuclear fusion. Essentially, two smaller elements can fuse together under the extreme pressures of the interior of a star. And that's what created all the larger elements, like everything we know today and everything you're made of. And after those stars died and exploded, all those ingredients came rushing out of the star into the universe, further enriching stellar clouds in the universe, which eventually gave rise to us.